Today we'll be looking at how the TI-83 or 84 calculator can be used when doing statistical work with correlation and regression. And we know how difficult the formulas for correlation and regression are, and we know how much time it takes to compute them if you try to do it manually or step by step. But if you try using the TI-83 or 84 calculator, you get your answer in minutes, and you save yourself the errors from estimation and from manual errors that we make when we calculate. So today we'll be looking at how to find the value of R, the correlation coefficient, and how to find the value of R squared, the coefficient of determination. We'll also be looking at how to find the regression equation and how to test the hypothesis for a population correlation coefficient. Let us consider the table below. For example, suppose you're asked to find out if there's a relationship between the number of cars sold by different companies and the revenue generated. How do you use your calculator to solve this question? Since it has to do with relationship, we're looking at correlation and regression here. And also, you're asked to determine the coefficient of regression and the coefficient of determination and the coefficient of non-determination. So we have this table here. Here it shows us the company A through F, which we don't really need. What we're interested in is the relationship between the cars and the revenue generated. Now it's very logical to think that the revenue generated is going to be depending on the number of cars sold. So the number of cars sold is the independent variable, and the revenue generated is the dependent variable. So as we progress, we'll see how we can use the calculator to solve this question. The first step is to enter your values in the TI-83 or TI-84 calculator. You press Stat, which is the button right under the button that says DEL, and then when your cursor is on Edit, you click on 1, the first thing there, which is Edit as well, and then you enter your independent or your X variables, which in this question will be the number of cars. You enter it in L1, and then you enter your dependent or Y variables in L2, which will be the revenues generated. When you finish entering your values, you press Start again, and then you move the cursor using either the right or left arrows to Tests, and then when you're at Test, you scroll down all the way to the Lean Reg T test, and then you press Enter. Then when you're in this test, usually L1 is going to be in the place where it says X list, but if L1 is not already there, use the second key, the second button, and the number 1 button to choose L1 into X list, to put L1 into X list, and then you type L2 in Y list if it's not already there, using the second button and the number 2 button. Your frequency should be set to 1, number 1, but if it's not, put 1 where it says frequency, FREQ, and then your beta and the symbol for the population coefficient of regression should be set to not equal to 0, and then you hit Enter, and then you scroll down and you calculate your answers. It gives you your answers right away. Now if we look at the pictures to the right, we'll see that the correlation of regression, the coefficient of regression, is given as 0.98197988097, which is here in the calculators here. That's a coefficient of regression. So that's how the calculator gives you coefficient of regression. And then the coefficient of determination, R squared, is given by R squared equals 0.964284347, and the calculator, that's it here. But that's not all. How do you find the coefficient of non-determination? Well, the coefficient of non-determination It's just found by subtracting the coefficient of determination from 1. So coefficient of determination is 1 minus coefficient of determination. And if you do that with a calculator, 1 minus 0.96428 is going to be 0.357. Okay, assuming that the question also asks us to test the hypothesis, the null hypothesis, which usually states that the coefficient of the population coefficient of regression is equal to 0. And what this means is that there is a weak relationship. So the null hypothesis is stating that there is a weak relationship for the data in the table we're given. What do? And assuming it tells us that alpha equals 0.05. Well, we do everything that we've done in the previous slides. You put in your L1 value as the independent variable. You put in your L2 values as the dependent variable, and you go to tests and you go to lean reg t tests, just the way we did and arrived at the coefficient of regression, and all of this is the same thing we do for this one. So after we've done all of that, you see here in the first picture, you see where it says P. That's what we'll be interested in. We're interested in the value of P, which is given to us as 4.84 times 10 raised to the power minus 4. This E here means times 10 raised to the power minus 4. So if the value of P is less than or equal to alpha, the null hypothesis is usually rejected. But if P is greater than alpha, the null hypothesis is accepted. But in this case, P is less than alpha, because 4.84 times 10 raised to the power minus 4 is definitely less than 0.05, which will give us our value of alpha in the question that was just asked. So since 0.00484, which is what you get when you convert 4.84 times 10 raised to the power minus 4 to when you remove the exponential, the power, since 0.00484 is less than 0.05, the null hypothesis is rejected. So this means that there is a strong relationship, since the null hypothesis, which suggested a weak relationship, is rejected. So there's a strong relationship between the number of cars and the revenue generated. So, but assuming that P was greater than alpha, which is not in this case, but assuming P was greater than alpha, then the null hypothesis will not be rejected but will be accepted. And this will mean that there is no relationship between the two variables, that there's no relationship between the number of cars sold and the revenue generated, or that there's a weak relationship. But in this case, there is a strong relationship because P is less than alpha, 0.05. It is also very possible to find the equation of the regression line. As the previous calculation performed, it gives you the A and the B values, which make up the regression line formula in the formula y equals A plus bx. And looking at the picture to the right, you see where it tells you what the general formula for the regression line should be, y equals A plus bx. And we also see the values of A giving us 0.3963210539, and we also see the value of B as 0.1061253165. So if we approximate those values as A equals 0.3963 and B equals 0.1061, regression equation y equals A plus bx will be given us this. That's easy, right?